Okay, pointers. Here we go. We did pointers last class or the class before? Last class. Good. Well, we're going to do them again because they are so important that we have to get this down. Otherwise, you're not going to pass this course. A C++ pointer can point to anything, well, anything that's pointable. All right. Anything that resides in memory, a pointer can point to. So, can it point to code? Yes, because your code is inside of memory. Can it point to the operating system? Yes. If the OS is loaded into RAM, you can point to it. Now, are you allowed to manipulate the operating system? Now that may cause a seg fault, but you can point to it all you want. So let's start having some fun here. So let's create an int a, great. That declares a variable a that stores the memory address of an integer, of where an integer resides. Then we'll have int b, b is on the stack, and we'll set it to 32, and then we'll have a equal to the memory location of b. So a after this point is storing or holds the memory location of b. A calculates the memory address. And we do dereference of a equals 64. Hopefully this is a review. Go to where a is pointing and store 64 there, not 32. Since a is pointing to b, b now has the value of 64. We good? Great. Heap pointer, hey, this should look familiar. Create a new integer on the heap. So let's make sure this is clear. What is a? A is a pointer. What part of memory, or where in memory does a reside? Static stack, so it's on the stack, and it contains a memory address of?
Nothing right now.
We set it equal to something. An integer on the heap, right. So a is on the stack. It holds the memory address of an integer that's on the heap. You can manipulate like before and then delete it afterwards. All right, arrays. ARY, remember that's really a pointer that points to the stack like I was showing you. You can create an A that points to it. And then here's the other syntax. We're going to do a plus 10, dereference it equal to 50 is the same as this down here. They are actually the same thing. This is really a shorthand of that above. The compiler really generates this from that. All right, now let's do some trickiness. Let's create B on the stack set to 300. Create A on the stack that's going to hold the memory reference of an integer, hold the memory reference of B. Great. Now let's create a variable D on the stack that's a pointer to a double. Then let's set it equal to A. Right? Still legal. Then let's dereference D and store 3.14159. What's the value of B? Let's see what we got. Okay, for pointers. So we have what? Int a equals, oh, it's b. B equals 300. Create a variable pointer a, set it equal to the memory of b. Create another pointer to a double, set it equal to a itself. Dereference d to equal 3.14159. Okay, and then all right, so let's see if that does compile. Yep, it compiles. Perfectly legal. What's B?
thinking 300. I think there's a reason for that, but I can't really remember.
Well, okay, let's go.
I'm not sure if B is left alone because it's an integer.
Is that too light? Marker's slowly dying. No, we're good. All right. So B equals 300. A equals a pointer to B. D equals also a pointer to B. Now, why is that the case? Because at this line, we just copy the memory address from A into D, and then we pretend it's now a double. So then D, which is pointing here, is going to try and set it to 3.14159. So what's B? How about this? Is B going to be 300? No. Let's find out what B is. -2, 6. I bet you all saw that coming.
Utter garbage.
It's garbage. Now what's going to be more annoying, or more amusing, and let's see if the compiler did it. Let's see what A is. And let's see what D is. Because you would think A and D are the same, and it might be. But they're not. Oh, that's good. Oh, that's good. Why are they not the same? Didn't we just set them to be the same right here? D is equal to A. Why is A different than D?
I guess since you're changing it from an integer to a double.
Right. How many bytes is a double?
Twice as many as
It's 8. A pointer is 8. An integer is 4. So when you set B to 3.14, you're setting all 4 of those bytes and only 4 of the bytes of A equal to whatever 3.14 or 159 is as a double. So that's why A got manipulated as well. But only half of A. Because notice that this half was perfectly fine. All right. Is this good or bad? Or neutral? What's the fallout of this? Because the compiler did not complain whatsoever.
It won't tell you when there's a problem. You have to
What?
go and look.
Right. It won't tell you when there's a problem, but in certain times it's going to be very nice that you can just create a pointer and just, all right, look compiler, just trust me. I know what I'm doing, and do it. The creators of C, they have about 4 lines that.
Faith.
What's that?
It's got to have that blind faith.
One of the things they said is rule number 1: we will always trust the programmer. Right, the blind faith. We will always trust the programmer. Huh. So what's the value of B when I ask you an assignment? Just say undefined. I could, if you take architecture, you'll be able to calculate what its value should be, but we're going to go with undefined because also the other problem is we don't know what the Indianness is, so it's undefined. And when I say Indian, that is with an E, not an I. So which way does it end? Yeah. All right, pointers can point to other things, functions, other pointers, arrays, and objects. Ooh, why would we want to point to other pointers?
Because you can.
Because you can. All right. Void star means you are creating a pointer to something. All right. Hopefully you see that these things are getting a little complicated. All right, class organization, public, private, and protected are going, switching gears. Forgot to do the transition. We're jumping from pointers and now we're going to talk about OOP inside of Java and C++. All right, enforce through access keywords. So you have public, private, and protected, just like in Java. Each member is prefixed with the keyword. C++, they're done in sections, as I showed you beforehand with that code. And there's something called friend, which if two classes are friends, they can reach into each other's private member variables. There we go. Got to make sure I say that correctly, because I always want to say something else. Oh, what does that mean in C++? If they're friends, they can reach in and break encapsulation, which is bad. So therefore, C++ friends are bad. All right? Everyone got that? Yeah. Yeah. There's no friends. Well, you can, but they're always bad friends in C++. Okay. Java and C++, Java public class extends B, and C++ is just class A : public B. Just stick with that transition for now, and life will be simpler. The reason why I'm giving you a lot of just do it this way is C++ is a huge language with so many little corner cases. Just do it this way, you're going to be okay. You can do multiple inheritances, but we're not going to. Wow, I'm just skipping all sorts of things. Parametric polymorphism, aka when you use generics. Did you use generics in OOP? Like a linked list could be of different types? Yeah. So C++ has that. They're called templates. It's called parametric polymorphism. We're going to get to that later. Pointers. So pointers in Java. Hey, when you create a string class, it was a pointer. str was actually a pointer. In C++, you just have to be explicit about it. Oh, hey, look, C++ has a string class. Notice that it's a lowercase s. Java, you can only point to objects. C++, you can point to anything that's pointable. All right, this is where things get important. mkdir04. Wow, we're doing a lot of different things today. Okay, let's create an object. What object do you want to create? I know I'm asking you. Come on, it can be anything.
Dinosaur.
Dinosaur, all right. Dinosaur.cpp. All right, so let's create a class. Dinosaur. All right. Oh, hey, look. When you create a class in C++, end it with a semicolon. There, end it with a semicolon. Okay, I'm going to make my life easy. No, I'm not. I'm going to make it hard. I've taken that back. I'm going to make it easy. Int main, because I'm going to show you how that evolves. Ha ha ha. All right. So what public functions do we want here? How about a speak function? We're going to do it this way for now. Right? rar. Anything else? A run function. Let's see, what would run do? Oh, we got to pass it a distance, right?
Yeah.
Okay. Void run. So we probably need to give it a, we'll give it a private variable of int amount ran. Oh wait, do y'all prefer snake case or camel case? This is snake case. This is camel case. Good, we're doing snake case. All right. Okay. So let's go create a dinosaur. We're going to create a dinosaur on the heap or the stack. And by the way, start logging in.
Yeah, but
On the heap? Alright, so we'll go dinosaur star dino equals new dinosaur. Let's see if that compiles. It did. Alright, well let's compile and run it. It does nothing. Okay. Actually, if I were to Valgrind this, would there be an issue? Let's start there. I'm jumping around too much.
no.
Let's see what happens. Valgrind. Oh no, lost 4 bytes.
Create an object. And
We didn't delete it. Yep. Alright, let's go do that. So we have the dino, and then we're going to delete him. Huh. Oops, that was the wrong G++ command. Hey there, everything was freed. Great. Okay. Good. Let's see, what else can we do here? You want to give it, what's that?
you can have like some variables, like whether it has wings.
Okay, wings. Trying to think of something more dynamic, like maybe it's a name. Name? Hey look, it's a pointer. Probably should have a setter, right? Set. Let's see. Okay. So here we can call dino. Ooh, we're going to do an arrow. Set name. What do we want to call him?
T-Rex.
T-Rex. All right, let's see if that works. Let's see. Cannot convert. Oh, you can't convert it? Oh, because it's a star. That's right. So we need to go to new std string. So we're going to create a new string on the heap. There we go. Beautiful. Oh no, we lost 32 bytes. What happened?
Well, the name is a pointer,
Here's a new, right? Where's the delete?
so
There is no delete. Where do we delete it?
I guess before you delete that.
Right, so here's the problem. We want to delete it right here, but we can't because string is private, right? So C++ has a function that's called the deconstructor, and it is called when your class is destroyed or deallocated. So this function is going to be called when you call delete. All right? So in here, this is where we can delete string. Or I shouldn't say string, I should say name. And then we should set name equal to null. Okay? So now if we run it, everything's been freed. Okay. Now, what's the other problem we have? That might be a little hard to see. What's the value of amount ran? but we haven't set it to anything. We increment it. Problem here is amount ran has not been set, so it could be anything when this program runs. Java had a solution to this, and so does C++. You create the constructor, which is called when you create new, and the amount ran can set it to 0. Now, to keep yourself out of trouble, if you have pointers, set them equal to null. That way you'll get actual good errors when you mess up. So now if I go dyno ran or run 1024, I don't want to do that. I want to save it and then run it. And then I've run a total of 1,000. There we go. Or maybe now that I have a name, I should do that instead. Now we have a name. Oh, that didn't work out. What did it just print out? Memory address. We need to dereference that thing. All right, probably should add a space. Oh, it's so picky. All right, there we go. T-Rex ran a total of 1,000. Perfect. Okay, how are we doing so far? So, now let's go over back to here. It's behave the same with constructors. So I just showed you constructors. Perfect. Arrays. Let's see. So, oh yeah, here we go. This is good. We're going to do arrays. We're doing a lot of code today. Yeah, we're doing good. Ooh. So the question is, was this legal code inside of Java? I'm sorry, that's rhetorical. This is not legal code inside of Java. Sorry, didn't mean to be rhetorical. Because you can't create arrays on the stack inside of Java, but you can on the heap. So it creates 20 ints. You can also do the same thing with your other ones. So let's go to for classes. Here we go. We could also do this. All right. Now, this is going to be interesting. What does this do? Yeah, I get used to reading code and reading it explicitly. That's why I keep asking these questions. I'm not trying to be mean. It's just you got to get through this. So what is dynos itself? It's not good guess, but it's not quite an array. Oh, it wasn't you? Whoever said array. Good guess, not quite. Array list is Java. So dynos is a pointer. Remember, it's a pointer. And what is it pointing to? Because this is the other syntax for a pointer. It is pointing to an array, but where does that array reside?
With dynos.
I'm sorry?
With dynos.
No, the array is made up of 20 dinosaurs, yes. But where in memory does that array exist? It's not on the heap because there's no new. Well, the other two options are static or the stack. It's non-static because that would be a standard cosine. So it creates 20 dinosaurs on the stack. So it takes your function and puts 20 dinosaurs inside of that function. What's nice about that is you don't have to delete it. Just watch, we're going to Valgrind in it. And we're going to get some seg faults, actually. But that's okay. Or maybe not. So create 20 of it, and then it's done. Great. Because it automatically deallocated the dinosaurs when we return it from the main. That just sounds funny. Deallocating dinosaurs. Killing them. Now, the reason why I was surprised is you usually want something like this. Because you don't want to try and delete something. 1, 2, 3. Unless it actually exists. So I don't quite know why that passed. But I'm glad it did. So that is going to be more accurate code. Okay? Alright. So we already did pointers to arrays. That's great. Constructors are the same thing. We just went through constructors. You can also add parameters to your constructor. So for example, if you had dinosaur with a constant string Is that me? Oh, there's somebody out there. Okay. And we can then call set name, passing in name. That way when we go down here, we could comment out this code and pass in t-rex. And then when we run it, it then has t-rex because I called it from the constructor. Look familiar? From OOP? Maybe? Alright, great. The destructor or the deconstructor, it sounds like an evil villain name, right? The destructor. So that's where you want to delete everything.
Create all those dinosaurs just to kill them.
Just to kill them all. Destroy them. Okay.
Actually, in a way, it's kind of worse because it's almost like it didn't exist to begin with.
The dinosaurs? Or
Yeah.
wait, yeah. Oh yeah, because you just wipe them off, and now their memory is gone. All right. In C++, the semantics of A equals B can be specified. AKA, in C++, you can overwrite what the equals operator does. You could have it do something else, like not equals or multiplication. Why? I don't know, but you can.
Yeah, I was about to ask that. Why would you ever want to do that?
To confuse everyone else.
Right. So you can overload methods, and you did this in Java, and we just did in C++, because we have a constructor called dinosaur, and then a constructor called dinosaur that's passed a string. That's fine, and that's okay. But you can do overriding. So if you inherit, you can override the class as well. And yes, for example, in C++, you can override equals, plus, multiplication, and double equals can be defined just like methods. We are going to do this later, but not right now. For example, you can have matrix and then override the plus matrix of another one. And this kind of makes sense in the matrix example, because if you want to add two matrices, obviously you just want to do the plus. Could you do this in Java? You have two matrix objects, can you just add them? No. You can't override plus. You'd have to call it matrix.add matrix, and then it would return. Java allows you to do it this way. Of course, then you could overload a plus to do multiplication, but whatever. The rest of this is just to show you that C++ and Java are going to have some subtle differences that are going to be really annoying, and here's one that hopefully you will not encounter in this class, because I try to avoid this at all costs. So let teacher be a subclass of employee. You did your whole hierarchy, right? You have employee and then teacher. So teacher is an employee, but employee is not necessarily a teacher, right? Okay. So employee variable in Java, you have employee E, and you have E equals new teacher. That means that that E points to, when you call .e promote, on Java, you're calling, well, actually, which one are you calling? Are you calling teachers promote or employees promote? Well, maybe y'all didn't do this. So in Java, you're calling teachers promote. In C++, you're going to call employees promote. Because C++ doesn't know that it's a teacher. It just knows it's a pointer to an employee. So it's going to call employees promote and not teacher. While Java keeps track of what class it actually is. Y'all didn't encounter that in OOP or in Java? You must have. But anyways, hopefully this will never happen because it's really annoying. There are so many features I don't have time to go through it all. We are not going to assign the project. Well, we might. Do we have time? Ooh, we'll do Lab 5. So we can at least do Lab 5 today.
Are you gonna go back to second o'clock?
Yes, but I don't, it looks like I'm not going to have time for that in order to give you lab time. So I'll give you Lab 5 today, and then we're going to redo Lab 4 next class period.